This
waiting,
conference
I think,
will
one
now
more
be
minute.
recorded.
Okay, so it's 5 minutes after, so let's go ahead and start. So last time we met 2 weeks ago, we went through and talked about the universal quick disconnects. Hang on here, by the way, I'm getting, I have my colleague, I think, calling into the old meeting. So I will. Yeah, sorry. Let's hang on here. I'm getting several requests that they are calling into the old meeting. So I'm just gonna quickly send out information to the ones that are contacting. Okay, well, hopefully we can get the other ones here on board shortly. So last time we talked about universal quick disconnects. I'm just gonna, I wanted to ask if there were any questions regarding that, but I would like my colleague to join first. Mark Springer, he's the one that is working on it. And therefore, maybe we can hold the questions until hopefully he's joining here as well. Otherwise, are there any other general opens? No. Okay. And you guys can see this screen, I hope. It's kind of.
Yes, we can.
Yeah, awesome. Okay, I got 3 screens going, so and it doesn't show me which one that is shared. Yeah, so what I wanted to go through today and talk about was cooling fluid, and I hope that we can have a good discussion regarding this. And if we have time to get to it, we can also talk about the CDU parameters. So it's really the cooling distribution unit of what type of parameters, if when you're choosing a CDU, what should you consider? And that's basically what I wanted to talk about today. So I started putting a list together regarding the cooling fluid. And it's really, we talked about also last time in last meeting that of putting together a general wetted materials list of common materials that occur in the cooling loop. And here our near-term focus is the cooling loop from the CDU through the rack and back, right? So that's the cooling loop that we're focusing on. So it's the technology cooling system, if we're using the same terminology as used in ASHRAE, and as well the cooling loop through then the Datacom equipment cooling system, DECS. So we're using the same terminology as used in ASHRAE instead of creating a different terminology. So it really includes the ingredients of the manifold, connectors, CDU, and server fluid loop, whatever you're cooling on your server itself, right? So with cold plates and piping and everything else. And I put together a list of some common wetted materials. And it's a list that we have generated here at Intel, but we also submitted part of it here to ASHRAE. So it can be seen, and we can also reference ASHRAE and say, okay, these are the materials that commonly occur in the TCS loop. And that's really, in order to educate the users about what wetted materials that are there, but it's also in order to again, educate in order for them to understand that all wetted materials really needs to be taken into account. These are just some common wetted materials, but for each installation, you really need to determine what all the wetted materials are in order to make sure that you have material compatibility with the fluid, the cooling fluid that you're using. And this is really where the fluid suppliers come in. And that's why I wanted to have this discussion as well, right? Part of what we wanted to do here in the work group is really being able to, we need to put in a fluid operating range as well. So we'll talk about that. But it's really being able to, in OCP, I don't think that we want to limit the type of cooling fluids that we're using, but allowing different types of cooling fluids instead. And when I'm saying different types of cooling fluids, it's really water-based with additives, right? And it's a propylene glycol water, and it's dielectric fluids. So being able to discuss those, so I'm hoping here of getting information from fluid suppliers as well, of being able to share, right, of what is this design considerations that you need to take into account when thinking about the different fluids. Is there any feedback on this at this point?
Dustin Dimitru from IBM. Can you hear me?
I hear someone very, very faint. Is that just me?
I heard somebody back there.
Yeah, it was Dustin.
It was Dustin that was talking?
Having microphone issues.
Oh, yeah. That was a little bit better.
Is it better? Sorry,
yes.
my better headset died, and I'm going with the lower end one. But so my general question is, and I guess this is only the second meeting I've joined it, and so if this is clear, you can point me to something, please do. But I'm just wondering what is the goal of this exercise, or is this a white paper this group is trying to put out? Is this a formal specification that this group is putting out? I mean, right now, I see your list of materials, and I think we've talked about you referenced ASHRAE a couple of times. This material is in ASHRAE already. To me right now, it seems like if this is going to be a white paper, it's really going to just be repeating a lot of stuff that's out in the industry, and I'm just wonder what the value is. And so I was wondering if you could help clarify what the goal of the work group is at this point.
Yeah, and it's really providing both. So it's providing specification, OCP specification for liquid cooling solutions, as well as providing additional material such as white papers. My attempt is not to reinvent the wheel, right? But we can reference ASHRAE as much as we can, right? But we also need to make sure. So I think that ASHRAE is just talking about requirements for water with additives. Is that correct, or?
That's true. So the recent white paper that's not published yet will be published here in hopefully a couple of weeks. It was focused on water, just water as a coolant.
Yes, and I think that part of what we want to do is making sure that there are other options for cooling fluids, and what are the design considerations that we need to take into account for those, of not limiting it to one, to water only in this forum.
Okay, that's fair. I just wanted to make, I look
Sure.
at the wetted materials list here, and and for better or worse, I mean, it just seems like it's the same material that's in several other places in the industry, and I want this to be valuable, and my experience is the more places stuff just gets repeated, the more opportunity there is for confusion, and I really want to avoid confusion in the industry, because I think the industry is already confused on this whole topic. So
I agree. I think that the industry is confused on the topic, and part of this is, so we can discuss if it makes sense to have the wetted material, common wetted materials here, or if we're just referencing. Or, I mean, we can say that common wetted materials at this particular snapshot in time are the ones presented here, right? And then we can reference, because I believe that ASHRAE is going to update their list of wetted materials as we go along, right? As new suppliers and new materials are being used. Is that correct?
Yeah, I mean all the information in ASHRAE gets updated on some regular cadence, right? And as new things get brought onto the market, we update those things, and so.
Yeah. So I was thinking of referencing then ASHRAE, of saying if you need a more current list, here is an example, right? But at least this would then allow fluid suppliers to be able to talk about, here's some fluids that show material compatibility with the operating ranges and the common wetted materials that are in there. If you have any other additional wetted materials, then we need to evaluate those, right? But having a starting point of saying that, hey, this is, again, of not only focusing on water, but having water with additives, propylene glycol, water, and then dielectric, right? Fluids, of at least giving the users a choice of what type of cooling fluids that would work best for them, right? And this is really where you're kind of going down the somewhat of a tricky line, right? And this is within OCP, because we want interchangeability as much as possible, right? In the sense, as we were talking about for universal QDs, of interchangeability. That's really what OCP is about. But there's not, from a cooling fluid perspective, there's not a common cooling fluid that several different suppliers provide. There's always different additives and different concentrations, and again, different types of cooling fluids as well, which really makes that a tricky line, right? Of being able to say, we want to be able to have interchangeability. You want to be able to, for example, ship your charge components and plug it into your rack here, right? So if you have a charge server, you plug it in. But we need to know what type of fluid that is in that system. And since it's also, OCP is about interchangeability and multiple suppliers, right? And when it comes to the cooling fluid, that's when those two things are in odds. Because again, we don't have multiple suppliers providing the same type of cooling fluid. So that's causing any comments on that? Dustin, your take?
Yeah, no, I mean, I think it's, one side, talking about, if the goal is interoperability, my first thought would be that you figure out a single fluid. You don't try to go to 10 different fluids, because I think your likelihood of doing 10 different fluids and getting some commonality is almost impossible. But on the other hand, I think that if there is the ability to put out data, and there is testing and things that could be shared in this forum that say, hey, these materials do work with these types of fluids, I think that's valuable also. I guess and I think that's what I was questioning, versus, I'm looking at your table 1 here. This is just a common set of materials that could be available in liquid cooling loops, and to me that's good information, but it's not moving towards a specification. And so that's what I was trying to
No.
figure out. So
Exactly. And that's why again, that's why my comment regarding that I'm hoping that we can have a good discussion with fluid suppliers, right? I'll be able to share this is the type of testing that we would do in order to ensure that we have material compatibility, right? Because we started as well at Intel a couple of years ago when we started to look into different cooling fluids. We were walking down the path really of saying let's make sure that we have one fluid. When again, interchangeability, it's a big thing, right? That would make life much easier for the users themselves, right? And it's just not of course, talking to fluid suppliers, it's that wasn't the viable path to go down. So a viable path instead was to provide of saying, here are wetted materials. What type of testing would you do in order to ensure that you have compatibility with these wetted materials? And please share that testing with us and give us the name of the fluids that are compatible, right? So that's what I'm really hoping for, but that will be a lot of that would really fall on the fluid suppliers, right?
Yep, agreed.
Any other comments?
This is Steve Harrington from Childine. One comment is that if you hook up a system which has, anti-corrosion additive A into a system that's filled with anti-corrosion additive B, what happens?
Yeah.
Or do you have to drain any subsystem before you hook it up? The other thing that we run into is the anti-corrosion additive people don't tell you what's in them, except
Exactly.
in cryptic MSDSs, and and some of them are toxic to fish, so that you can't, like if you have a supercomputer with lots of fluid, if you dump it all down the drain, you might cause an environmental disaster of some sort. So that's another thing to keep in mind.
Yeah, and part of this, I think, I agree with those comments, and it's it will have to be, the recommendation would be, if you're choosing a specific cooling fluid for your installation, you need to check with the supplier in order to make sure that you know how to as well, right, of getting rid of it if you need to discharge the system. And as well as, because some parts as well, they be shipped either charged with liquid or uncharged. And depending upon the installation that you have, there's no fluid supplier, right, that will come and say, yeah, of course you can mix my fluid with someone else's fluid. We have no idea what the interaction between the two will do, and there's nothing, of course, that any of them will guarantee, right? Because as exactly as you said, the additives are, and the amounts of them are not common knowledge, but it's part of the secret sauce for each fluid supplier. So that, again, that's why I'm saying it's I believe that that's the path to go down, of saying, again, of here's the, of putting it more onto the suppliers themselves. Any other comment here? Okay. So, and please review this as well, right? So the notes will be posted on the wiki page. So hopefully you can go in there, you can listen to the recording of this meeting and see the notes and the documentation there, and last meeting as well for them, where we discussed the universal quick disconnect. And then was hoping for a discussion as well around the fluid operating range. So I put some parameters down here as well. Of, again, if we're saying that we have a wetted materials list, we also need to at least be able to provide to the suppliers of what type of range that we're temperature and life expectancy range that we're considering. So what I have here, and I'm looking for feedback as well, is really shipping and storage temperature range, which I have put down here between -40 Celsius to 75 Celsius. -40 is one of those commonly used for shipping and storage temperatures, but again, that is based upon that you're charging your system when you ship it. That is a charge system, right? And you want to make sure that it's not freezing and cracking. And -40 is, again, one of those common.
Jessica, do you think you could move the window there so we can see the table?
I don't know what you're seeing. I apologize for that.
I'm seeing a join the meeting as and a box that needs to be checked okay.
Oh,
well, maybe. Okay.
Yeah, I can see the I can see the Word document. So.
Okay, good. Dale, does it work?
It must just be a problem with my interface, but it won't go away, so I'm okay. Thanks.
Okay. Yeah, I mean, all that shipping and storage temperature range, -40 to 75 Celsius. I have also operating temperature between 17 Celsius to 65 Celsius. And the lower range there was really coming from the ASHRAE recommendation of the 17C dew point. And life expectancy 10 years or longer. So I was hoping to get some comments on that as well.
So this is I'm not sure if someone else was talking. This is Steve from Chilldine again. As far as the operating temperature, we can say whatever we want it to be, but it's really going to be up to the maximum temperature at which the CPUs are going to throttle. Because if for some reason someone leaves the CPUs on full power running LinPack and turns off the water flow rate, which I've seen happen before, turns off the liquid cooling system, then it's going to get up to 100 C. So everything you need to, if that's the throttling point of the chip, so everything you put in the system has to be good to 100 C.
Okay, so of taking, basically of saying taking brisk analysis into it as well, if anything, if fluid supply is shut off.
Right, or something breaks down, or there's all kinds of problems that can arise, but it's important to realize that your real temperature limit is the maximum operating temperature of the CPU, not whatever you think it is. And then the other thing is if you say we're going to go down to 40 below, then you pretty much define the fluid as 50-50 or so ethylene glycol and water. And at that point, you're throwing away a lot of thermal performance you would get from pure water just for ease of shipping. And the question, I mean, does that make sense?
Yeah, and these are the discussions that I was really hoping for. So it's and how many suppliers do really ship system charged as well?
Well,
right?
I think we don't, but other people do.
Yeah.
So the people that do ship them charged are going to want it good to 40 below, and the people that don't are going to want it just regular old water, which has better cooling performance than e.g. water solutions. So.
Yeah.
We ship, because Cam from Cool IT, we ship power systems charged, and we've had no issues with PG15.
PG15. And what's the freezing point for that?
It's -6.
-6 Celsius. Okay.
But you got to remember when it freezes, it gels. It doesn't freeze like water freezes and stuff blows up. It just turns into a slush.
And what's Sorry,
I was just going to make a comment on the operating temperature. I think I would define operating temperature maybe in this range, but there could be a max temperature rating that we would want to place on it to cover things, sort of transient issues like Steve was describing.
Yeah.
So if there's a max temperature of 100, but an operating temperature, that may make a difference for the suppliers. Does that make sense, Steve?
Yeah. That makes sense in order to say, if failure occurs of, that the fluid is turned off or for whatever other reason, what is happening to the cooling fluid up to this max temperature?
That's right. Yeah. So we'd want to get that case covered. But it wouldn't necessarily be the normal operating temperature over its life cycle.
Yep. I thought that.
Steve, does that make sense?
Yeah, absolutely. It's just an unusual condition, but one you have to design for a little bit.
Exactly. Making sure that nothing is, that you're not increasing the risk, right?
Sure. Yeah, it's a real condition, so probably capture that.
Yep. I'm taking notes on the side here too. I will add it into this document later. And is it just of maybe I wanted to follow up here also saying of shipping Cool IT equipment down to -6. What's the thermal expansion of PG15? Does that matter?
I don't have that off the top of my head. Yeah. Sorry, I can get it for you though.
I was just curious of if it's something that we want to put in along those lines as well, right?
Yeah, fair enough.
Yep. Cool. Yeah, and then anything regarding life expectancy? Is this along the lines of?
I guess my comment is I don't know what you mean by life. I mean, life could be a lot of things. Is that how long the fluid will last without having to top it off? Is that how long the inhibitors in the fluid will last? Water. I mean, if the fluid's going to be in there after 10 years.
Yes.
For the most part.
If it has the quality that you want and the performance that you want, that's a different question.
Right, exactly. And by life, do you mean how do you do maintenance on it, or do you have to do maintenance on the loop? Do you have to put inhibitors in it every 6 months, every 5 years? I think life is too general.
Okay, yeah. So I would put in a note of defining. Or even putting. We can discuss of even if we need to have it in, right? But because part of it will be of being able to for each of the fluid suppliers, right, of being able to say what's the maintenance for their particular fluid. How often should you monitor? How often should you check for if you need to add any additives to it and so on, right? So there will not be necessarily any general overall guidelines on that. That's a good point. Thank you. And then
yeah, the required maintenance interval might be more important than life, because I think a lot of sites will tend not to do any maintenance, so that sort of becomes the life.
Yeah, of saying if you don't do any maintenance at all, how long would you expect, you know? But again, it needs to be on a case-to-case basis, depending upon the type of weather materials you have and so on, right? And the fluid, of course. And what type of other requirements that you have in there regarding, for example, filters and fluid quality and so on, right? Because you need to ensure that you're not, for example, clogging up the CPU cold plate and stuff like that, right? Any other comments on that? Nope. Okay. And then I just wanted to also run through here. Oops, I think I have that somewhere else. And it was just of having initial discussion here as well regarding CDU. So I'm expecting there to be, again, I mean, so some of the wetted materials are, of course, in the CDU itself. So the CDU options that we have is in-rack CDU, external CDU, or virtual CDU, right? Virtual CDU just meaning we're using the facility water. And liquid-to-liquid CDU, liquid-to-air CDUs, and highlight the importance of ensuring material compatibility with the cooling fluid of materials that are in there. So we started putting a list together as well of really parameters to consider for evaluating fluid compatibility in commercially available CDUs. And the different parameters here that I have is L10 pump life. So really of taking the time for 10% of the sample population to reach failure. And this is really data that you can get from the pump manufacturer. System mean time between failures. Calculate the mean time between failure for critical CDU components, you know, again, pumps and other components in there. Mechanical, what type of potential mechanical, depending upon the design of the CDU, there will have different risks in different areas. It could, for example, be leak testing and compression testing for seals, gaskets, and so on. Chemical could also be depending upon the CDU design itself of where potential risk areas are. So if you want to make sure that you're checking the compatibility between the wetted materials with the cooling fluid, there are some parts of the CDU that might be of more interest than the others. Heat exchanger, the thermal performance really of understanding of what the effect on the fluid and heat exchanger thermal performance is, as you may be considering different fluids here, since we're, again, not trying to specify a specific fluid. The pump performance, be able to compare pump curves and efficiency. Does that change over time? Is that something that, you know, that you need to know? So you build in, when you're setting up and designing your system, you're building in if there's any type of degradation of the performance over time. Thermal cycling, operating temperatures. So, for example, will there be thermal issues with the ramping between the min and max operating temperatures? Using different ramp rates, dwell time, cycle count, things like that. and thermal cycling, non-operating temperature. So that's really, again, considering shipping temperatures, storage temperatures, and so on. So this is an initial list of that, and I'm again looking for feedback here. And again, depending upon what the CDU looks like, right? It's hard to come up with some specific test that needs to be done for all CDUs being considered, because it really should depend upon the type of test that you do, should depend upon the CDU design and the cooling fluid that you have chosen. Okay, if there's no comments regarding that, I will put this information on the wiki page as well. So please go in and look there and think about it and provide your feedback. Appreciate it.
Hi, this is Steve from Childine again.
Yeah.
As far as the pump life, did someone already mention that? Nobody will tell you what the pump life is.
Okay.
Because they don't know what the coolant additives are and how that affects the wear on the seal and all that kind of stuff. So, whereas if they say this is a city water pump and we know exactly what the service is and the temperature and all that kind of stuff, they might be able to tell you the life. But once it goes out of that kind of comfortable zone where everyone's 100% familiar with what you're doing, they can't tell you. Because it depends on, like I said, temperature. Basically, if you got a centrifugal pump, you got two bearings and a seal. That's the only thing that's going to break.
Yeah.
And you can probably figure out how long the bearings are going to last based on temperature and load and so on. But it's really hard to figure out how long the seal is going to last. So anyway, I just because I've gone down this road before where people said, "Oh, how long it's going to last?" And I called the pump manufacturer and he says, "Oh, it's going to last forever." I'm like, well, thanks. So anyway.
Would it make sense to do something along the lines of saying in a life expectancy and in a specific fluid or in water,
I think,
and then trying to, yeah.
Well, the most important factor there is, did you buy the pump from a quality manufacturer that put in good bearings, or did you buy it from the cheapest guy you could find and the bearings are terrible? So, how do you assess that? I mean, anyway, it's just like I said, it's I've tried to do it and it wasn't easy, and I still don't really have an answer. The life of the CDU is going to be, if it's related to the life of the pump, and it probably generally is, it's going to depend on how good you are at filtering stuff and how carefully you picked out your coolant additive to be compatible with the seal materials. And of course, it depends on what water you fill it up with. If it's hard water, if it's got any abrasive stuff in it at all, then it's not going to last. So, and I think that's kind of the wide-ranging big problem about this whole liquid cooling is that the people who understand it are different from the people who are buying it and trying to implement it at the data centers, and there's a lot of mystery there. So anyway.
And I think education is needed, right?
Right.
As well.
Absolutely. And yes, that's a big thing. And you have to be able to dole out the education in bite-sized chunks, so that people can, understand it one step at a time. But because like I said, we went through this. How long is my CDU going to last? Well, it's like, well, we could do accelerated testing. We can run it on hot water, or spin the pump to higher speeds. But is that realistic or not?
Do you have any?
So, Steve, your comment applies to the MTBF as well, right?
Yeah, I know. Yeah, exactly. Because I've also had conversations with other people who make CDUs, for example, and the MTBF, usually the first thing that breaks is the thing that you didn't think was going to break, due to the operator who did something that you didn't expect. So that's hard to figure. but if if you say, well, these are the however many pieces that are on all the time and are subject to a lot of wear, which one's going to break first? With us, we just started replacing whatever broke with the higher quality part, and that just eliminated all the failures. So now we know what the MTBF is, but we can say it's a pretty long time. But
so given that complexity that you outlined, what would you recommend as would you recommend just ignoring the life and mean time before failures, or how would we deal with that in a spec?
No, I'm just what I'm saying is that based on my experience trying to ask the pump manufacturers how long their pump is going to last in an application that they're not very, very familiar with, they have no idea. And so they'll just tell you it'll last forever because they're salesmen and that's what they do. But as far as MTBF, I think, you would say, how long does the bearings last? Who made the bearings? How long does the seal last? But, the most important thing to do is to say, is this pump from a reputable manufacturer? That's number one, because I know what happens, particularly in the open compute world, is everybody's trying to get things as cheap as possible. So you just have to be careful to not, because I could tell you 100 ways to screw up a pump design, because we design pumps sometimes, but if like you're looking at like a swimming pool pump, for example, would be a typical thing that's on maybe 8 hours a day, and that probably lasts like 15 years. So but if you make a mistake and the pump cavitates a little bit once in a while, then your lifetime just dropped to significantly less. So what I'm saying is that it's a big, tough problem that takes a lot of engineering to figure out, and it's not easy. And so this list of things to look at kind of implies that it's not that hard to figure out. But like I said, I tried, and I basically said, buy the best quality parts you can for all the moving parts, and then it'll last a long time. And if you don't do that, things will break, customers will get mad. So
is this something from your experience then that you be able to provide as well, of saying, okay, this is the best known method? Because again, it's part of educating, right? And if we can put information together in for example, a white paper of saying, okay, this is recommendations for how you can go about doing this.
Yeah, I could do it, but we're talking about like a 3 month, 3 to 6 month, $200,000 engineering project for each CDU. You know what I mean? And that's why anyway, it's not easy to figure out how long it's going to last. And like the biggest problem with having things not last a long time is mistakes that you made during the design process that you maybe didn't notice, that you were inadvertently, putting the pump in a bad spot in terms of the inlet conditioning isn't good, or like I said, it's cavitating under certain circumstances. There's a lot of mistakes you can make, and anyway, I'm sorry. I'm just the point. I think that the takeaway from this is that you have to be careful, and that calculating the lifetime of a CDU is not a simple calculation, because the most likely failure mode is the one that you didn't expect. Especially when you hand it off to data center operators that are all super smart people but don't know anything about pumps and so on. So they may do things that
you didn't think about. Yeah.
Yeah, exactly.
Are any of these parameters defined for specific fluid or condition, typically?
For example, for water without additives or...
Right. So if there was a specific fluid, is there any kind of sort of industry standard for defining what that life might be.
So I think, well, this is Dustin again. One of my questions is, again, I come back to what is the goal here?
Mm-hmm.
I mean, is the goal just to go out and ask manufacturers to fill in data sheets for their CDUs for each of these parameters, or is the goal here to put together a specification for a CDU? Again, I mean, those are two very different and, exercises. I mean, if the goal is to just have CDU vendors provide this information, I mean, you can go to their website and they probably have some of this information. I agree with others, Steve and others, about the pump life and the mean time between failure and all that kind of stuff. It's so dependent on how is it operated, what's the control methodology that it's operated in within the CDU, what are the fluids, how do you maintain the system? Again, to try to do this in any sort of way where I'll give you my view is there's no way we could do this across a range of different fluids and think we will come to one answer that works across the board. My experience, I've done a lot of liquid cooling system designs, is every single one is custom because of one thing or the other, and I don't see a way of bridging a whole range of different fluids and a whole range of liquid cooling designs into one set of specifications. So
yeah, that's kind of what I was getting at. It's like, what will be useful to the folks that would be accessing this information? Is it useful to know?
Right. I mean, it seems to me that ASHRAE is doing that. I mean, ASHRAE is writing the broad guideline on liquid cooling and what are the issues and what are the questions that you should ask. And it seems like I thought this group was going to be focused on writing open spec that would provide interoperability, realizing that would be a subset of the total and what would be covered by the ASHRAE guide. But if we're going to allow non-water based fluids and all sorts of other options, I mean, it just is becoming more of a guide, and I'm not clear how it would be different than the ASHRAE guides.
Except that the ASHRAE guide is doing only water-based, right?
Dustin would probably be good to answer that.
Yeah, I hesitated a little. The most recent white paper that will come out, in the next month or so, hopefully, is focused just on water. I don't recall. Oh, I take that back. I do know in the liquid cooling datacom book, there is some information in there on immersion cooling and other things. So we must capture other fluids in there. I doubt that the material in there is as comprehensive as it is for water. But I generally think the focus has been water in ASHRAE. But I agree with Dale's comment. Is again, I thought the goal of this was on developing some type of specification, not necessarily just general guidance. I think there are plenty of other avenues where general guidance is available. So.
Okay, I hear you.
Here's another idea just to throw out there is, because this is such a complicated problem, perhaps the first step might be to define a liquid cooling manifold for an OCP rack, and such that it could fit the connectors that Cool IT and Asetek uses and the connectors that we use as well, and whoever else. That might be a little tiny, bite to start with. That's just an idea.
Yeah, and it's on the list, and maybe we were walking down the wrong path here of going towards wetted materials. We started with UQDs, and but yeah, it's really of defining keep out zones, right, in the OCP rack for manifold, as well as determine where connector locations are located in the OCP rack as well. So that's also, it's on the near-term focus list. And it might be a better start to to go over there then. Okay, great. Thank you for all the input. If there's no other questions or comments or opens.
Jessica, when should we look on the wiki for the updated versions?
They should be posted by tomorrow. Okay, cool. Well, thank you so much, and talk to you in 2 weeks. Bye.
Okay, see ya.